Okay, so this is the final lesson for this unit, and in my opinion, it's one of the hardest ones. So I'm gonna go very slowly through this, and I've made some changes to what I've done last time. This is the notes from last time, and I made some changes to it because of the gas evacuations. I wasn't able to do a nice sheet for you for some of the changes I made, but I do have an extra handout that we'll be inserting in here as well. Okay, so in grade 9, when we were looking at linear relations, they want you to look at patterns and then be able to graph those patterns and come up with a formula with those patterns. In grade 10, it's a different approach that's taken to this, and in my opinion, it's actually an easier approach, right? So I'm going to do a mix of what they want you to know in grade 9 versus what's taught in grade 10, because they cover the same concept through different angles, right? So honestly, I'd like to teach you the grade 10 version, but I'm mandated to teach you the grade 9 version because the grade 10 version is what you need in your senior science classes. Okay. So what I'm talking about here is we give an equation and you're asked to create a graph. That's what the first half of these notes are going to be. Then the second half is we have a graph. How do we come up with the equation? So going the reverse way, right? So there's a couple of different strategies. All right, now the first question is we're given this equation d is equal to 90t. And we want to graph this. So how do we graph this? Is we pick any x values you want and find out the matching y values. And those become the points that we want to plot. Now, typically, we pick nice small numbers, 0, 1, 2, 3, 4, and 5, because it just makes our graph easier to plot. It doesn't matter. You don't have to use these numbers. You can use negative numbers. You can use bigger numbers, right? Whatever you want. What you do is you take whatever numbers you chose and you plug it into the equation. So you go, our equation is d is equal to 90t, and you plug in the value of t, or the x value. So 90 times 0 equals 0, right? For the second one, we have 90 times 1 equals 90, right? So continue this down. Use the formula, plug in your x value, or your t value here, and find the y value, right? Plug it into the equation. 90 times 2, what does that equal? 90 times 3, what does it equal? 90 times 4, what does it equal? And finally, 90 times 5. All right? Plug it through your calculators. All right? So what do we have? What's 90 times 2? What's 9 times 2? 180, right? 9 times 2 is 18. Add a 0, 180. 90 times 3? 270. Right? 90 times 4? 360. And, all right, 90 times 5? 450. All right? Now, we're given the equation here. Hello, ladies. Yeah. So we used our equation to find our data values, right? Now, typically, up to this point, you had the table and you had to find the equation, but the whole point of this is connecting everything together. Looking at our table, do you see a pattern in the y values? How much is it increasing by each time? How much is it decreasing by each time? Right. Serenity, what do you see?
It goes up by 90.
Goes up by 90 each time, right? That's the pattern, right? Right? And we're going to spend some more time looking at that, right? And notice that the 90 shows up as the number that we multiply our variable by. Hello, Joey, take a seat.
Oh, you found your phone.
So we need to graph our data now. Right? We give an equation, we create data, now we can graph it. Right? We set up our axes. So we're going to go like, see how well I can draw on the screen. All right. We go like this. Go like this. A ruler comes in handy. All right. And we go. First decision to make is what goes on the x, what goes on the y. All right. So, what goes on the x-axis? Is it time or is it distance? Yes, Jessica.
Time?
Time, yeah. The one on the left-hand column, right? So time, and this is distance. Now, if we didn't have a data table, you can actually tell it from the equation as well, right? From the equation, we have d is equal to 90t. The variable on the left side, right? This is our y variable, and this is always going to be our x. So from our equation, we can tell as well, right? All right. So we've decided that. So the next decision is spacing. All right. So looking at our time, 0, 1, 2, 3, 4, 5. What is our spacing we want to do? Yes, Theo.
I'd recommend going up by 90.
Up by 90? Our time goes between 0 and 5.
Oh, sorry, not time.
Yeah. So we're going for this.
Ones then.
Go up by ones, right? And so if you should have a look at maybe further down, do they ask for half an hour or something like that? You may want to adjust it, but go up by one. So you start off with 0, you go up by 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And Theo is thinking one step ahead of me and suggested that we should go for 90s for our y. Yeah, let's do that. Let's go up by 90s. So each line, right? 90, 180, 270, 360, 480, right? So let's plot the data now, right? When x is 0, when x is 0, d is 0, or t is 0. And when it's 1, it's 90. When it's 2, it's 180. So all the graphs that we're going to do in this unit are straight lines. So if you end up something not as a straight line, chances are you made an error on one of your calculations. So it should be a clue to you. Say, hey, I need to double check this. So draw your line, draw your point, then take your ruler and draw a straight line through there. There we go. Okay. So this is like a really important skill to have, like just being able to create those graphs. Okay. So I'll give you a couple of seconds to finish that off and we'll continue on. Thank you, Serenity. I'll change that to 450. I added wrong. Thank you on that. Okay. Okay, the second question asks, how long does it take Suri to drive 630 kilometers? Right? Using the graph. Right? So there's two ways we can answer this. So we're going to do it both ways. Using the graph, we can read out the value, or we can do this from the equation. So step 1, to use the graph, we need to find where 630 on the graph is. So I need to extend my data points. We have 450. The next line would be 540. Right? The line after that would be, we're adding 90 to each time, which would be 630. Right? And that's as far as we need to go, right? So at 630 kilometers, we read off the value. So going this way, what is the y value or the x value, the t? It is 7. And then the units for time, I should have included that, is in hours. So the answer is 7 hours. Now, if we wanted to use the equation to verify our answer, we say d is equal to 90t, and we're told that the distance is 630. So we replace the d with 630, and we solve for t. So how do we solve for t? What do we do with that 90? Yes, Joey?
In this case, since it's multiplying t, we have to divide it.
You have to divide it to cancel it out, right? Divide it. So we'll say t is equal to 630 divided by 90, which is equal to 7, right? So you end up with the same answer. Okay? So you can always check your answer, which is a great thing. Okay. So we're not just practicing graphing, we're also practicing looking at different kinds of graphs. All right? Looking at the next set of data values, we have x is equal to all these different values, but the y value is equal to 4, right? So let's create the graph, right? Since x can be positive or negative, we need to include that in our graph, the positive part of x and the negative part of x, and y is only positive. So we'll draw a graph maybe that looks like this. At the halfway point, we'll go up, and we go like this. So we can do positive and negative values of x. Okay? So this is x here, and this is y here. Okay. Right. We make our scale. So this is going up by 1, so that'll be 1, 2, 3, 4. Going down 1, negative 1, negative 2, negative 3, negative 4. And on the y's, we go 1, 2, 3. We're going up by ones. 1, 2, 3, 4. 1, 2, 3, 4. I'll just put a 5 here. You don't have to write down every single number, right? You can just label like the major lines. So you can go by 5s or 2s or something like that. So I'll do that. So the graph of this is you plot the points. You go 0 is at 4. So I'll change my colors here. Maybe I should start off with negative 3 is at 4. Negative 2 is at 4. 1's at negative 4. We just go like this. These are the values that we're given. Right? Now, up to now, what we've been looking at is like a line, but a slanted line. Right? So this does not have any slant to it. So it makes a difference on our equation. Okay? Our normal process, I've got to draw a line here. All right? Draw a line through there. Right? Right. Our normal process is to say, hey, compare how are the y values increasing. Right? That's what we normally do. Right? But the increase here, it's 0. It's not changing. Right? So what could be an equation for this line where it says it doesn't matter what the x value is, but the y value is always negative or always positive 4. What could be an equation that says that? Right? It's a bit different, right? So a horizontal line is always y equal to its value with no x included, right? Because it doesn't matter what the value of x is. The value of y is always equal to 4. That's what an equation, a line like this would look like. So it doesn't follow the normal format that we do, right? So that would be the equation of that line. Let's go over here. Okay. Let's do the next one here. So we're given a set of data points, and we want to come up with the equation and graph it. All right. So I'm doing a recap of what we did before, and later on we're just looking at the graph and coming up with the equation. All right. So I used the wrong grid here. If we look at our values here, if you think of this as our x values or y values, right? Our y values are always negative, right? So let's draw, our x values are always positive. So let's draw our grid to look like this instead of the center ones I'd put there. Let's put it from here and going along the top. Right? Right? And this is where 0 is. This is our x values, or t. This is where our y values are, which is d. So we're looking at the fourth quadrant here. Right? Okay. So looking at our data, our x values, or t values, how should we do the spacing? What should each line be? What should be going up by each time? So the value 0, 1, 2, 3, 4, 5. We need to be able to fit all that information on there. So what should we go up by? Yes, Theo?
Like 2s?
Each line worth 2? Right? So if we went each line worth 2, this would be 2.
No.
Sorry? You want every second line or worth 2?
Yeah, every second line is what I meant.
Every second line worth 2, basically going up by ones?
Yeah, going up by 1s.
But yeah, we don't need to label every line, so we can go 2, 4, 6. It's nicer to just go up by 2s like this, right? You don't have to label every single point. Makes our graph look a little bit neater. 8, right? Now, looking at our y values, let's look at, it's good to look at the pattern. What pattern do you see here? What is it increasing by or decreasing by each time? Right? How much is it going up by each time? Yes, Theo?
Going up by 0.25?
Yeah. So we started at -2, went down to -1.75, so it increased in value, right? So it's a positive value, it's getting closer to the right, right? So that will help us determine our spacing, okay? So a good spacing now would be maybe 0.25 or 0.5, a double that. So what do you guys want to do? Right? 0.25? Stick with that, right? So if each line is worth 0.25, so that'd be 0.25 or -0.25, right? And we don't need to write every single value down, but it takes 4 0.25s to get to a 1, right? So you go 1, 2, 3. The fourth line, let's write down -1.0, right? We're going up by 0.25 each time, right? Then we go -1.25, -1.5, -1.75, and -2 be another 4 lines lower, right? A little bit harder to graph, right? But these are the things you need to take into consideration when you're graphing. Right? And that's the hardest part. All right. So next is just plotting your data points. All right? Reading off the graph. We had 0 and -2. 0 and -2 would be a spot right there. Then we have 1 and -1.75. So starting with 1 on the x, going down to -1.75, it would be right there. 2 and -1.5 would be right there. 3 and -1.25 would be there. 4 and -1 would be right there. And 5 and -1.75 would be right there. Right? So then we come up and we draw a straight line. So grab your ruler and draw a straight line through those points. Okay. Okay. So we now need to come up with the equation of this line. Okay? And we're going to follow the same format we did since the first class. Right? So we set up our equation. D is equal to something times T. Right? The something is how much we're going up by each time, or down by each time. So how much are we going up by each time? Yes, Joey?
2.5.
So D times 0.25, right? Now we need to test this equation to figure out how much did we overshoot or undershoot by. So what do we need to add and subtract to make it work? So you pick any data point and test it out, right? So let's pick the first one. It has a 0 in it. It makes the math easier. So let's pick the first one. D for when 0.25 times 0 is equal to 0. Right? Our calculation gave 0, but it should have been -2. Yes, Theo?
Therefore, you should subtract 2.
So therefore, we need to subtract 2. Right? So if you go subtract 2, we get -2. Then we double check with something else. So what data point do you want to double check with? Pick one of the other ones, any one you want. Right? Yes, Joey? Which one do you want to pick?
1?
Sure. Pick one. Plug it in. So D is equal to 0.25 times 1 minus 2. So we have 0.25 times 1 is 0.25 minus 2, which is equal to -1.75, and check, check. It worked, right? So that's how we come up with the equation, right? Okay. Okay. So our equation, and I guess we still need to write that down. D is equal to 0.25t minus 2. Okay. Okay. How about we take a break right now? We're gonna take this slowly, and we'll get started again in like 15 minutes. So let's begin. So with the next question, I want you to, thank you, Ivy, is graph it yourself, right? So I've given you the x values or the a values here. Determine the b values by using this equation. Okay? Then graph it, right? I'll give you guys like a 1 minute head start. And if you're struggling, just look up onto the screen and I will start filling in the information that you can see, right? Enough for you still working here. I put it up on the screen. The spacing that I used here does not have to be the same spacing as you used, right? So I just want to make the graph bigger. So on the x-axis, the value of A, I made each 1.5 just to stretch it out, right? And on the y-axis, the value of B, I went up by 3s. And that may not have been the smartest choice because as a result, I did have to estimate some of my points because it didn't fall right at crosshairs of numbers, but that's okay, right? We can't always just figure out a scale where our numbers fall exactly at crosshairs. There is always going to be some sort of estimation. When we set up our spacing, we want to make it as easy as possible, right? Now you could have gone up by 2s or something like that, maybe it would have been easier. I just decided to go up by 3s, right? But your graph should look like this. You guys get a graph that sort of looks like this? Yeah? No? Okay. So just be careful when you do your calculations that you end up with the same numbers, right? And you start off with this one, 0, then up to 15. And you go to your next one, 1 and 13. It's easy to reverse it, right? It's not always smallest to biggest. Sometimes it goes biggest to smallest. Right? Okay. So the next graph here, okay, we need to figure out what are the y values for these given x, right? Using this equation. So the equation that they give us is x is equal to -3. So what is this saying? Yes, Jessica.
That it doesn't matter what the y is.
It doesn't matter what the y is, right? The values of x is always going to be -3. So we can just, if we're graphing this, we pick convenient values of y for ourselves then, right? How about we pick, I don't know, we got crosshairs here. So how about we pick -2, -1, 0, 1, 2. They'll fit it. Or I'd go 0, 1, 2, 3, 4, right? I just already have a crosshairs there. I figured that might be easy, right? So on our x scale, we'll say each one of these is worth 1. So 1, 2, 3, 4. That's 5 here. That's -5 here, right? On the y-axis, this is 5 here and -5 here. So how does this look? Right? If the x value is always -3 for our given points. So our graph would look like this, right? So this is, then we use a ruler. I'm not using a ruler here to be quick. And this line would stretch out like this. Now this is similar to like the second graph I think we did, right? So this is a line, but with no slant. This is a purely vertical line. So notice the equation is x is equal to a number, right? So this one here, it was a horizontal line. It was y equal to something. So if I gave you pictures of two different graphs, one with a horizontal line and with a vertical line, you can tell me the equation of the line by just seeing x is equal to whatever number or y is equal to whatever number, right? You should be able to say that. Or if I gave you that equation, y is equal to, say, 7, you should be able to describe it to me. Oh, it's a horizontal line, and then the value of y is always 7, and it doesn't matter what the x value is. Okay? So let's skip this next one. We're not going to do this one. Okay? And I originally had planned to do this. This is my notes from when I taught Math 9, I don't know, like 3 or 4 years ago. And I think I jumped to this question too quickly. So I made an extra handout, which I just gave you, and we're going to go through those questions before coming to do this one. Okay? So go to the extra page with the 3 graphs I gave you. So this is the second part of the lesson. Now, here, we're given a graph.
Joey doesn't have this.
Oh, Joey doesn't have it. Oh, sorry, Joey. So with these set of graphs, our goal is to look at the graph and come up with the equation. This is the hardest part of this unit. Okay. So there is 2 approaches. There's a grade 9 approach I can teach you, and maybe a grade 10 approach as well. We'll see how it goes. Okay. So the easiest approach that we can take is we take that graph and we create a table from it. And then we can just do what we did since day 1 in this unit, right? We just figure out how much is increasing by. So let's call, I didn't have a chance to label my axes this morning. Let's just call this x here. This is our x-axis. We'll call this variable here y. And we'll come up with an equation where it says y is equal to something. Okay? So we need to come up with a table. Right? That's how we do our equations. And we just right on here, we can go x, y. Right? And let's come up with some values here. So when x is equal to 0, the y value is 4. So you just read points right off the line. So we write that down. 0, 4. and just pick 3 points. You don't need to do every single point that's there, but pick 3 so we have something to compare with. Then we go, it's nice to go consecutively, all right? So we go 1, and the value is 6. 1, and the value is 6. And the last one, 2, and the value is 8. 2, and the value is 8. So now we have a table, right? This is what we did in the day 1, right? We come up with the equation. So our first step is to see how much are we increasing by each time. Yes, Serenity?
Goes up by 2.
Goes up by 2. And this became our multiplier for our x variable, right? Our coefficient. So we start off with our equation. Is we go y is equal to 2x. And then we need to figure out how do we adjust it. Do we add or subtract? So we plug in one of the data points and test it. So let's try the first one here. Our x value is 0, so 2 times 0 equals 0. What should have it equaled?
4.
4. So how do we need to adjust our equation? Yes, Joey?
Add 4.
Add 4. All right. Add 4. Okay. Now we check to see if our equation is right. So you pick any other point. Let's take the last one just because it's there. So we go y is equal to 2 times x. So x value is 2 plus 4. So 4 plus 4. Yes, 8 and 8. So our equation is good. So you just created an equation from the graph. That's like the hardest part of this. I'm going to make it a little trickier though. Okay? Why?
He just said it was the hardest part.
It is the hardest part.
That's the hardest part.
But
You confuse us.
because lines can look differently. Okay, now, unfortunately,
Oh, don't look back.
on your photocopy, the minor lines didn't come through here. I don't know, the photocopier, I guess, just didn't have enough toner. But we can read it off my graph. Okay, so we have another line here, which we need to follow a similar process to determine the equation of this line. Okay, so once again, we set up our table. We go x, y. We'll call this the x-axis. I didn't label these. This is our y-axis. And we'll come up with an equation. So just pick points off the line. And it's easy to go consecutively. Here we got 0 here, and the value is 4. Then we have a point at 2, and the value here is 8. Then at 4, we have the value here is 12. Okay? 4, 12. Okay? Now, we do our approach as what we did before. Okay? So we go, how much is it increasing by each time? 4. And 4. So that becomes our multiplier. Okay? So we go y is equal to 4x. Okay? So we need to test this equation now. Yes, Theo?
I don't think that's going to work.
Yeah, this is where it gets a little trickier.
Okay.
All right?
Sure.
So let's test it out. So we plug this in. Right? So you don't need to write this down. It is not going to work. Mr. Doywall is being tricky. So we plug it in. equals 0. All right? So then our normal process is, okay, what do we add or subtract? We have to add 4 to make this work, right? So we add 4. That works for that one. Then we try this equation out for another point. Let's try it out for this point. So y is equal to 4x plus 4. You don't need to write this down, all right? Because we're not going to erase it all. Then you get mad at me. You go 4 times 4 plus 4. So that's 16 plus 4 equals 20. Our equation didn't work. So there's something different about this graph compared to everything we've done before. Yes, Serenity?
The x value goes up by 2.
The x value goes up by 2. Everything we've done up to this point, if we go back to our notes, everything we've done up to this point, the x values have always gone up by 1. Right? You look through back. Everything, x value goes 1. So our approach needs to change. And then what we did before wasn't incorrect. It was just a smaller subset of the type of questions that you can come across with. So let's go back to this thing here. Not that one. Where did I go? Graph. Here. Okay. When we do the how much is it increasing by, right? Everything up to that point, we're saying, hey, x went up a value of 2. Sorry, y went up for a value of 2 for every value 1 over x, right? Everything's been like for one value of x. Here, we're not increasing by a value of 1. So that's why this equation is not working, right? Because this has to be increasing for 1. What's the increase for 1 value of x, right? So how do we do that, right? So we go, hey, what is the x value increasing by? 2. 2, right? So instead of multiplying by 4, we have to multiply by how much is it increasing for per 1 value of x. So it's increasing by 4 over 2. So you take the y increase divided by the x increase. That tells you how much it's increasing by for 1 increment of x. And if you can simplify that, simplify it, right? So 4 over 2 becomes just 2x, right? So that becomes 2x, okay? So then we erased all this that Mr. Dollywall took you through just for the pain of it, okay? And we approach it the exact same way we did before. We go, okay, we're using the formula. How much are we overshooting by or undershooting by? We plug it in. You go, y is equal to 2 times 0 equals 0. What do we need to add or subtract? 4, yeah. So we need to add 4 to make this work. Add 4. All right? And we double check. Y is equal to 2 times 4, right? Plus 4. So you have 8 plus 4, which is equal to 12. And yes, it works. Right? In fact, what I did this morning when I was creating these graphs, I used the exact same graph here. And I just extended the graph, and instead of showing the values for every single 1 value of x, I just showed every second value of x. And hence, that's why they're the exact same equation. All right? It's just that line continued further down, and I just didn't show you every single point. I showed you every second point. All right? So let's try this one more time on here. So this is a simpler question than before. All right? So simpler question than what's on your notebooklet. Right? That's why I wanted to take you through this process, and hopefully it makes sense. So we have our x value and our y value. Okay? We go create our table, x and y. So when you're picking your points, it's important that you pick them consecutively or at least with even spacing, which it helps. That's how we create our equation, right? So we go for the first point. When x is 0, the y value this time is 6. So this is going to be a different equation. It's not the same graph. All right? When x is 2, the y value, does this show up on your graph? All right? Is there, which is on mine. It looks like it's, how many lines are there? We're going up by 2, so that's 9.5. Okay? When x is 2, and it's 9.5. Then when x is 4, oops, highlighter, 4, it's 12. 4 and 12. Okay. Way too easy, David? Good. Okay. There's a couple of different things I want to talk to you guys about. So I'm glad that you're finding it easy. Okay? So, just like we did before, what is the increase that you see in the y? How much is it going up by or down by each version of y? Yes, Theo?
It's going up by 1.
Oh, did I?
Just at 9.
Oh, is it just a 9?
I think so.
Oh, just a 9. Yeah, I read it wrong. 9. Okay.
It's going up by 3.
It's going up by 3. I read it right. And it's going up by 3. Okay. Yeah. And now this becomes our multiplier, right? Y is equal to 3x. And before we just leave it at 3, we check our x's. Is it going up by 1s? No. What's our x value going up by? 2. Each time we're going up by 2. So we divide that by 2. So 3 over 2x, right? When we first started this chapter, we could have done the exact same thing, but we were always just dividing by 1. That's why our equation didn't always worked out. It would have been 3 divided by 1. Our x is going up 1, it was just 3, right? So now, we plug it back in and see what adjustment we need to make the formula work. So for our first point here, we plug it in. Y is equal to 3 over 2 times 0 equals 0. What do we need to add or subtract to make it work? Yes, Theo?
Add 6?
Yeah. Is equal to 0. Oops. Equals 0. Should have equaled 6, so we need to add 6. Add 6, and it should work. So let's pick another point. Let's pick the last point here. Y is equal to 3 over 2 times the value of x, which is 4, plus 6. Okay. 3 times 4 is 12. Divided by 2 is 6. So 6 plus 6 equals 12. Yay, it worked. Okay. Now, that's grade 9. One thing I would like to extend this to is a tiny little bit of grade 10. Looking at, oh, what happened to my 6 there? 6. Looking at the equation here and the graph. Look at the equations. You can go back. Look at this number here. That's the number that we're always adding or subtracting. Where does it show up on the graph? You should notice it. It shows up. So here, where do you see where it shows up? Right? Where does it? Okay. Where is the 6? Right? Remember, this is relating y. Right? Where is the 4 in relation to y? Right? And if you go back to our notes, even this one, where is the -2? Look at that. So it's right there. And going back to here, it's the 4 is right there. And the 6 is right here. Yes, Serenity.
It's the first column.
It's the first one. It's actually where
It's
the
first.
y, the graphic, in these particular cases, that's where it starts, but the graph could have started in the negative because these lines can continue on this way, right? This value here is where the graph crosses the y-axis, okay? This value here is known as the y-intercept, and that's what you do in grade 10, right? It's where it crosses the y-axis. So looking at the graph, you don't even have to do any calculations. If you can see where it crosses the 0 on x, you can give me the y-intercept. Okay? Now, the next part is a little bit harder to tell. This 3/2. Okay? This you can get from a graph as well. And I'm not going to ask you to do this in grade 9 math, but you're going to do this in grade 10 math, grade 10 science. This is the way you're going to approach. This is known as the slope or rate. How quickly does the graph grow? It tells you the steepness of the graph. Okay? And the way you calculate the steepness of a graph is you pick any 2 points on the line and you create yourself a little triangle. Okay? Right? You create yourself a little triangle. And your rate or your slope is, I'm going to use a new symbol which you probably haven't seen before, a triangle y and a triangle x. Now the triangle is a Greek symbol meaning delta. That's how you pronounce it. It means change. So the slope or the rate, how fast it grows, is how much does it change in the y-axis in the same amount of span as it takes to change in the x-axis. So, right? So in here, from here to, oops, that's a bad, oh, let's go like this. From here to here, in the y-axis, we went from 9 to 12. It went up by 3. So our change in y is 3. How much time did it take in the x-axis? From here to here, we started at 2 and we went to 4. That took 2. Right? And that took 2. And that's how you come up by looking at the equation. Now you can create the table. That's what I'm expecting you to do in grade 9. Or if you're comfortable with this, you can try this approach because this is what you're going to be doing next time. And it doesn't matter what 2 points you pick. You're always going to get the same value, 3/2, right? Like I could have taken, let's see, this point here. Let's go black here. No, where are my colors? Go black, not black. I just used black. Let's use blue. I could have taken this point and this point, and it would have been the same answer. How far do we go up in this direction, and how far do we go in this direction, right? in this direction, in our y direction, I started at 16, sorry, at 6, went up to 15. So that's a difference of 9. I went up 9, right? In the other direction, I started at 0 and went all the way to 6. So that's an increase of 6 from 0 to 6. So what's the slope? And it is equal to 9 over 6. Right? And if you simplify that down, 3 goes into both numbers, is 3 over 2. So it doesn't matter which 2 points you pick on the triangle, it's always going to give you the same rate because it's growing at the same steepness. Right? Now, next year, you'll come across an equation that says any line can be represented by this formula. Y is equal to mx plus b. And you'll be seeing this in science classes and math classes for the rest of your high school career. Okay? Where m is your slope or your rate, and your b is your y-intercept. Slope, y-intercept. Okay? So, little peek into next year. So at grade 9, all you're required to do is recognize patterns, graph, and if you're given a graph, just pick up points and create your equations that way. This, even though if you may find it a little confusing now, is about 10 times faster than doing what we're doing in grade 9, once you get used to it. I wanted to show it to you because at around 3/4 of the way through grade 10, you start doing stuff with this. Okay, and let's just call it quits.